Hello everyone, and as you all know, we are doing the problem session based on the aromatic character, the resonating structures, and in this process we have already done two problems and now it's turn of problem number 3. So let us try to see what this problem is all about. So as you all can see directly, the problem is based on two compounds. So as you can see, we have taken two compounds, compound A and compound B. There is a minor difference between A and B, as you can see from the structure, and what actually you have to figure out in these two compounds, as you can read out the question, how many different aromatic cycles. So how many different aromatic cycles you can figure out, you can see in the compound A and B respectively. So let me try to explain it more fundamentally. As you can see, there are two compounds A and B. You have to see the compound A, you have to see the compound B separately, and what you have to find is how many different, for an example, you have taken A, you have to figure out, okay, this is a cycle which is aromatic in nature. Again, you can find another cycle which is again aromatic in nature, and you may find more cycles which are aromatic in nature and all different from each other. So that you have to find in A also and B also. B I have given as a variation, a minor difference from A. You can see the B has. So we will find in the two compounds respectively how many aromatic cycles we are going to get. We will start with A. So if you see A, then one thing you find immediately that in A, you see, if you see this part which I am encircling, you see this. In this part you can find this is cyclic. First of all, this is planar, flat. And now about cyclic conjugation, whether this ring carries a cyclic conjugation or not. Let us try to figure it out. I have already dealt this part earlier also. Let us do it once again. You can see a lone pair. Out of two lone pair, you should take just one. Lone pair, single, double, single, double. So in the cycle of 5 atoms, you have figured out, you have seen that all the 5 atoms are coming in the conjugation. So there is a presence of cyclic conjugation. And last thing is the Huckel's rule, whether it follows the Huckel's rule or not, that is 4n plus 2 pi electron. So you can simply count the number of electrons in the cyclic conjugation. From the lone pair you are going to get 2 electrons. From this pi bond again 2 electrons. And from this pi bond, 2 pi bonds, as you can see, 2 electrons. So if you count all, 2 plus 2 4 plus 2 6. So for n is equal to 1, you know this Huckel's rule, 4n plus 2 rule is going to give you the figure of 6. So you have found one aromatic cycle in the given compound. Okay. Now we have to find others also. So now coming back to the A1, we have already found, and now let us see if we can get other cycles as well. So immediately if you pay attention, you find a benzene ring also. You can see this. So not just the right cycle, but the left cycle is also cyclic in nature, first of all, planar in nature, and you have got the benzene. How you can see the benzene? You can see double, single, double, single, double. So there is a cyclic conjugation, and as you can count, there are 3 pi electrons each pi, 3 pi bonds, each pi bond contributes in 2 pi electrons. So overall there are 6 pi electron in the ring in cyclic conjugation. So again it's an aromatic ring, aromatic cycle. So 2 cycles, 2 aromatic rings you have already found. Now before giving your final eventual answer, you have to give a little bit of more attention to this compound, that is there any possibility to have 1 more or 2 more rings which are aromatic in nature. Let us try to find that presence. So now in order to find the presence of other cycle, what I did resonance of A. So you can see that I have started from A and have made one of the resonating structure, like as you can see. What I did, I found there is a conjugation, lone pair, single, double. So what I did, I just did the resonance, I just made the lone pair to float 1 position ahead to make a pi bond, as you can see, and simultaneously this pi bond is going to shift over this carbon, and this carbon, the one which gains the electron, gets the negative charge, and the oxygen which is from where the lone pair is going away is getting the positive charge. So from this resonating structure, can you see there is appearance of 1 more cycle? Let me make you realize what that cycle looks like. You see, you should see the cycle as the periphery made by the peripheral atoms. You see this. And if you count the number of atoms involved, 1, 2, 3, 4, 5, 6, 7, 8 and 9. All the peripheral atoms like this, 9 atoms. You take this as a cycle and try to see that all the atoms are sp2 hybridized. It's a cycle. The cycle is planar. And what about the cyclic conjugation? I will try to find whether there is a cyclic conjugation or not. And finally the Huckel's rule. So if I try to do so, you understand, what I found is like this. You see, there is a negative charge. You start from this carbon, this particular carbon, negative charge, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond. Again, I am repeating, minus charge, single, double, single, double, single, double, single, double. And in this process, you have come back to your original position. You have completed the whole cycle. And in this course, you have included all the 9 atoms of the cycle. So you straight away find, oh, there is a cyclic conjugation in this 9-membered cycle if you count. And let us try to find the total number of electrons, the pi electrons which are involved, because as you can understand, the 4n plus 2 pi electron rule should also be followed. So if you try to add all the electrons, so 2 electrons coming from the lone pair, what you see like this, and the pi electrons, 2 from here, 2 from here, 2 from here, and 2 from here. If you count all, 2 to 4 to 6 to 8 and to 10. Now in the cyclic conjugation you have 10 pi electrons. Is Huckel rule going to give you the figure of 10? Let us try to find. If you put the value of n is equal to 2, then you straight away see that 4 into 2 plus 2 is equal to 10. It means that this cycle follows the Huckel rule. So you have, just by making one proper resonating structure, can see that the cycle made by these peripheral atoms, 9-membered cycle, if you call it a complete cycle, if you don't see this bond will not come In the conjugation, at the peripheral atoms, there is a cyclic conjugation of 10 pi electrons, which again follows the Hucker's rule. So altogether you have found 3 cycles in the same compound, which can bring the aromatic character to the compound. So the answer is, the final answer is 3. This is, I have done the inspection of the compound A, and as I told you, we have another variation of compound A, a slight variation I have done, and we have compound B. And let us try to figure out how many aromatic ring you see. Before I have progress, you can pause the video and yourself can check the answer based on what I said. Otherwise, you can follow me. First of all, very easily I see one cycle which is aromatic, is not a rocket science, and as you can see, you have got this. And in this cycle, as you can believe, it's cyclic also, it's planar also. And now let us talk about the cyclic conjugation. You will get it. How? Lone pair, single, double, single, double. So you have seen there is a cyclic conjugation of electrons, and let us see the number of electrons involved in the cyclic conjugation. 2 from this lone pair, 2 from this pi bond, and again 2 from this pi bond. If you count all the electron, it is 2 plus 2 plus 2, 6 pi electron, and you know the 4n plus 2 rule is followed for n is equal to 1, and it gives you 6 pi electron. So you have got one, you have seen one of the aromatic rings which is possible amongst the possibilities. So one you have seen. Now coming on to the next part, what next you can see? The next you can see, you just observe the peripheral atoms and you observe this cycle as we did the last case of the compound A. You just bother about the peripheral atoms and make a cycle like this of 9, again 9 atoms. And as you can see, there is a cycle of 9 atoms. Let us see whether it's the cyclic conjugation is happening or not. So you start with a lone pair, single, double, single, double, single, double, single, double. And in this song, you have included all the 9 atoms which were ranging on the periphery. So there is a cyclic conjugation you have found. Now the total number of electrons, if you count, 2 lone pair, 2 from this pi bond, 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 and if you count all, 2 to 4 to 6 to 8 and to 10. And I have already told you the 4n plus 2 gives you value 10 for n is equal to 2, and n can be, as you know, it can be 0, 1, 2, anything, the non-negative integer. So you have again got the periphery making a different aromatic cycle other than the one you got in the previous slide. So 2 you have got till this point. Now let us try to see what next. So for next, I have shifted the electrons to make some proper resonating structure so that it can give the glimpse of if any possibility was there of other aromatic ring. So you see how I have done this. You start with the compound B and you just see there is a condition of resonance, lone pair, single, double. You shift this lone pair like this, and you know these electrons will shift to this carbon. As the lone pair shifted away from the oxygen, a plus charge came, a pi bond got formed from the lone pair, and the pi bond which shifted on this carbon is now a negative charge with a lone pair. After you have done this, you observe one very important thing, that this negative charge can still be in conjugation with this pi bond. What I am trying to say, minus single, double. So for this, what you can do, you can shift this lone pair here and the pi bond there. Why I am doing this, you will come to know in the next figure. As you did this, the lone pair now float as a pi bond, and this pi bond, it comes as a lone pair on this carbon and a minus charge comes. And as you did this resonating structure, you are amazed to see that you have got a benzene ring there. So a benzene ring appears, and you know that is also aromatic in nature. So altogether, two you got in earlier two different cycles, and one you have got this as the benzene. So altogether it will have 3 aromatic cycles. For the third one, you have to make some shifting of electrons to draw the proper resonating structure which can reflect the aromatic character as we have seen. So again, the final answer is 3. So both the compounds A and B, if you try to find it properly, you will get to see 3 aromatic cycles. So this was a beautiful problem, and I hope you must have understood this problem, and you must have got the idea behind what I am trying to say, how the aromatic character can be reflected in part of a compound. You don't have to take everything into account. Still you have a part of the compound which will reflect the aromatic character. Like this you have to do. So like this we will come up with more problems in future also. Hope you are understanding the problem series, and will meet you next. Till then, take a good care of yourself. Thank you very much.